Hi friends, welcome to my channel. So in this video we're going to start explain three problems related to house robber. So the three Leetcode problems are problem 198, 213 and 337. So in this video we're going to explain problem 198. So actually the relationships between these three questions are the following. So problems 198 and problem 213 essentially can be solved using the same code, and problem 337 involves binary tree. So in this video we're going to solve the problem 198 using dynamic programming. So first I'll read through the statement of the problem, and then we will do a simple analysis, and finally we share two formats of solutions. So first let's look at the problem statement. So there is a professional robber planning to rob houses along a street. So each house has a certain amount of money stashed. The only constraints stopping you from robbing each of them is that adjacent houses have security systems connected, and it will automatically contact the police if two adjacent houses were broken into on the same night. So the question is, given an integer array called nums representing the amount of money of each house, return the maximum amount of money so we can rob tonight without alerting the police. So here are two examples. So in example 1, so the output is 4. So in the explanation it says that the robber can rob the first one to collect one unit of money, and rob the third one with index 2, collecting 3 units of money. So in total you get 4. So in example 2, so the output is 12. So house 1, house 3, and house 5. So 2 plus 9 plus 1, that is 12. So we are going to go into details during the analysis, so why we get this kind of numbers. So the constraints on this problem are the following. First, the nums array has length bounded above by 100. So this actually defines the problem size. And the second one is that so each of the house has money in between 0 and 400. So this actually is important. So it's not always non-negative, right? So that's the main statement of the problem. So now let's look at the problem here. So here we plan to give a DP solution. So also we actually hope to use this DP to solve the house robber 2, right? So for this actually first I'm going to use two DP tables. So DPI, DP rob I, and DP not rob I. So the interpretation of these two DP tables are the following. So DP rob I is defined as if rob house I, so the maximum amount of money can be collected up to house I. So DP not rob I means that if do not rob house I, so the max amount of money can be collected up to I. So if we use this interpretation, actually the recursion relation is straightforward. So if we look at DP rob I, so in other words, we plan to rob house I, then we want to collect the money at house I. In other words, that's nums I. Then we cannot rob house I minus 1 due to the problem constraint. So the money we can get up to this house is nums I plus DP not rob house I minus 1. So this is the update for DP rob. And for DP not rob I, so actually the maximum amount of money we can collect is the maximum of the two options. So because we do not rob house I, so we can choose to rob house I minus 1 or not, right? So that's why the max is the two items. One is dp rob I minus 1, and the other is dp not rob I minus 1. In other words, we can rob house I minus 1, or we can choose not to rob house I minus 1. So that's the update for dp not rob. So at the end, we just need to return the max of all these things. So that's the return format here. So here is a quick walkthrough for example 1 and example 2. So if we run this recursion relation, so we can get a dp rob and dp not rob table final states for the two examples. So for example, in example 1, so dp rob is given here and dp not rob is given here. So the maximal numbers in the two tables are 4, so we can return 4. And in example 2, so the two tables have the final state given here, and the return is 12, right? So that's actually the main analysis. So next we can do the code. So for doing the code, first I'm going to write a verbose solution, so using the above dp table, and then we want to make some optimizations or simplify the formats. So first, for this, I'm going to track the length of nums, so just for convenience. And then we are going to initialize the dp table, dp rob, so it's going to be a list of length n, and dp not rob, that's also a list of length n. So first, we can initialize the first element in dp rob. So if we rob the first house, so the number of money we can get is nothing but num0. So the first element in dp not rob 0 will be 0 as initialized. So next we just need to do a for loop. So let's see, we'll call this one the preparation and initialization. So next is the main logic, so the dp update. So for this, let's do this for I in range, so 1 to n. The reason we start from 1 because we have set the numbers for the first house, and then we can update dp rob I. So by the recursion relation, so in this case we rob house I, so then the money in house I is this amount, and then we cannot rob house I minus 1, so it's dp not rob, so I minus 1. So this is the update for dp rob I. Then we can update dp not rob I. So in this case, so we can actually determine to rob dp I minus 1 or not. So if we rob, so it's dp rob I minus 1, otherwise it will be dp not rob I minus 1, right? So then actually we just need to return the max of these things. So it's max of max dp rob and max dp not rob. That's actually a full solution to this problem. So this format of writing actually is very verbose. So for example here, the return. So actually in this for loop, we can introduce another running variable to track the maximum number, right? So let's first do a special case check. Yeah, it passes one example 2. Now let's do a generic case check. Yeah, it passes all the cases. So with that said, let's do another format solution with some simplifications. So let's copy this function signature, and then we will mark this one as v1. So actually we do not need to specify this dp tables, we just need to track the variables. So for this, I can use dp rob first to be nums0 and dp not rob to be 0, And also we initialize a result global variable, it's dp_job, and then we can do the iteration. So n is the same as the length of the nums array. And next we do the iteration. So for I in range 1 to m. Then let's first use a temp variable to save dp_job, and then we do the update. So dp_job, so it's the previous state. So it's dp nums I plus the dp not job, right? So we do not job the house I minus 1. Then dp not job is going to be the maximum of dp job and dp not job. So this will be the dp not job, because we haven't updated this one, so we can use its previous state, and then the temp, right? Then for the result variable, so we can use a max of the previous state and the dp job and dp not job. So this result variable actually does the comparison in the process of iterating. So finally we just need to return the result. Actually, this format of writing is essentially the same as the first one, but we use less space. So with that said, let's first do a special case check. Yeah, it passes the example 2. So now let's do a generic case check. Yeah, it passes all the cases. So I guess that's about it for this specific problem. So next we are going to look at the second one, that is problem 213 in a follow-up video. Yeah, this is it for this video. Thank you very much.